All right. Hello, everybody. Hope everything's going well. Today, we are going to talk about function notation. So this is not anything new. This is stuff you got in Algebra 1. So this should be a nice little quick review for you. We'll then extend it out a little bit for you to make things a little bit of a challenge, but nothing too crazy. So if you remember correctly, back in Algebra 1, you talked about equations all the time. And then you talked about function notation. Function notation was that f of x thing you learned. All right, so function notation takes an equation like y equals 2x plus 7 and takes out the y and replaces it with f of x. So you get f of x equals 2x plus 7. And f of x being the function part of this. Realize that it's not always f. Sometimes that f could be a g or an h or some other letter, but this is telling me this is a function of x, meaning I'm going to put some value in for x and it's going to give me out something else. All right, so the nice thing is function notation tells us what the input is, x is our input, and what the output is. F of x is the output, okay? Input being my domain, output being my range, some words we learned last section for you. All right, so for example, if we take f of x equals 2x plus 7, like we have here, and we said find f of negative 3. So what that's telling me to do is to take this negative 3 right here and make it x. So we're going to put it in where x is. So f of negative 3 is equal to 2 times, instead of x, I'm going to have that negative 3 in there, times negative 3 plus 7. And then I do PEMDAS. I just do my math. So 2 times negative 3 is negative 6 plus 7. So negative 6 plus 7 is 1. So f of negative 3 is equal to 1 is what you end up with there. Nice and straightforward. So we've done this. This isn't anything brand new, but that's where we're at. All right, so if we keep going on, I'm going to do a couple of examples, another example, and then I'm going to have you guys do one. So sometimes, like on this one, notice that up here we don't have just an f of x, we have an f of x and a g of x. So we have an f of x here, and we also have a g of x here. So now we need to pay attention to that letter in the front of our notation to tell us which function we're using. And this is where that function notation starts to be super handy, as we can have multiple functions we're dealing with, and based on the notation, we know which one we're using. All right, so if we want to find f of negative 9, that's telling me use the f function, so that's the green guy I highlighted up here, and I'm going to plug negative 9 in where x is. So f of negative 9 would be negative 5 times negative 9, because that's what x is, minus 14. Negative 5 times negative 9 is a positive 45 minus 14, which when I do that math, I get myself 31. So f of negative 9 is 31. All right, so remember this value here is what we're going to plug in for x. All right, now we're going to take a few minutes. I'm going to let you try this one, g of negative 7. All right, so hopefully you got through g of negative 7. You put your answer down. Let's see how we did. So we'll go through this real fast. So g is a little different, and that's why it's a little tricky. So if you messed it up, that's okay. This is called learning. So let's see what happens. So g of x is a little tricky for a couple different reasons. This little negative right here makes things a little tricky, and the fact that there are two x's. So that means I'm going to plug this negative 7 into both of those places, not just one. So that gives me negative 7 squared plus 9 times negative 7 minus 1. All right, so then I got to remember PEMDAS because I got to do things in the right order. So PEMDAS tells me I have to do exponents first. So I got to do this negative 7 squared first. Negative 7 times negative 7 is a positive 49. But I still have this negative out front floating there. Okay, then I got plus 9 times negative 7, which is plus negative 63, and then I have a minus 1. So I have negative 49 plus negative 63 minus 1, which when I do all that math gives me negative 113. So g, not f, g this time, because we use the g function, g of negative 7 is negative 13. So hopefully that's what you got when you went through that problem. All right, so another example we're going to work on together here is number 5. Number 5 is a little fun because it does this f thing twice and does math with it. So it's f of 1 minus f of negative 4. So that means I'm going to do f of 1, figure out what that is. f of negative 4, figure out what that is, and then I'm going to subtract them and figure out my final answer. So we're going to do the f of 1 piece in orange. So f of 1 is negative 5 times 1 minus 14. And we're going to do that f of negative 4 piece in this dark blue, brown, or dark blue or purple color, whatever it is. So we have minus, and we got to subtract all of this. So I'm going to put parentheses there, because if I don't do that, I usually only subtract that first term, and that's going to be a problem. So we have negative 5 times negative 4 minus 14. And now we just do our math. Okay. So negative 5 times 1 is negative 5 minus 14, which is negative 19. So that f of 1 turns into negative 19. Then I got this minus, that's 20 minus 14. So that's minus 6. So when I put those together, I get negative 19 minus 6, or negative 25 as my answer. All right, so the biggest key here is making sure you're keeping things a little bit neat and organized to help you out. All right. Another type of problem we have here is kind of working backwards. So notice this one says f of x equals 34. So that doesn't mean to put 34 in for x. That means put 34 in for f of x. So something to pay attention to. You got to make sure you're seeing and reading things the right way. Okay, so we're going to take this f of x here, and instead of putting our number they give us, it's not inside function notation. Notice it's over here by itself. So it's telling me f of x is 34. So I want to put it here where f of x is. So I get 34 is equal to 3x plus 19. And then I'm going to use my algebra skills to solve this thing. So that means I got to get this 19 over by subtracting it. So minus 19 minus 19. So that gives me 15 is equal to 3x. Divide by that 3 to get x by itself, and I find out that x equals 5. So that tells me that f of 5 is 34. So it asked me to find x, which is right here, but then the overall mathematical sentence would be there. So once again, I'm going to give you a few seconds. You try number 14. All right, hopefully you got through number 14 here and you figured it out, but let's do this real quick. So we got negative 62, because that's what f of x is equal to 3x plus 19. Subtract our 19 to get 3x by itself. So that's negative 81 is equal to 3x. Divide by the 3, and that gives me that x is negative 9 when I do that. All right, so that's the answer we were looking for on that problem. If you got it, nice job. If you didn't get it, see what step you messed up so we can try not to do that again next time. All right, the next thing we're going to talk about is this word problem here, and I know we're all scared because it's a word problem, and words only belong in English class, but we try to make math have some words too every once in a while. So it says Owen paid a landscaping company $108 for an initial lawn treatment, and then another $74 a month after that. The function p of t is equal to 108 plus 74t represents the total amount of money he will have paid after t months. So part A says find p of 24, and what that tells me is put 24 in for t. So I can do that. 108 plus 74 times 24. All right, I'm going to cheat here. I don't know that off the top of my head, so I'm going to bring up a calculator. All right, so we do 74, maybe, 74 times 24, and we add to that 108. So we get that p of 24 p of 24 is equal to, what was that? That was 1,884. Okay. And the big key here is, what does that represent? So I want you to take a second, type in over next door what you believe that represents. All right, so I believe that represents, so t is number of months, so 24 is two years worth of months, right? Because 12 months in a year. So what this is telling me is that Owen paid $884 over the first 2 years of lawn treatments. So to treat his lawn for 2 years, that's how much money he paid. That's what it represents. All right, let's look at part B here. So part B says, how long has Owen been receiving lawn service if he has paid a total of $2,994 to date? So total is what F or of P of T represents. So that means that this is my total. So that's going to go in where P of T is, and then I'm going to solve for T. So I'm going to go 2,994 is equal to 108 plus 74T. And I'm going to solve for T. So that means I got to subtract that 108. Okay, so that gives me 2,886 is equal to 74T. And just like before, I'm not doing that math in my head. So if I do 2,886 divided by 74, I get that T equals 39 months. So Owen has been receiving lawn service for 39 months. And we would write that out in a sentence because if they give us a question in words, we should give an answer in words. So we would write, Owen has received 39 months of lawn service. Okay, so we're going to make sure we answer our word problems with words. All right, one last example from me and one more try for you, and then we're done for our video today. All right, so this one looks a little funny, so that's why we're going to go through an example of it. So it says f of c plus 2. So this tells me that I'm using f, and I'm going to put c plus 2 in wherever x is. So I have f. I'm going to put, instead of x here, I'm going to put c plus 2. And then I'm just going to simplify. So we're going to try not to make this too crazy. So f of c plus 2 would be -4. Instead of x, I now have c plus 2 plus 9. Okay, so I put c plus 2 in where the x was. Then I just distribute and I do my math. So I go, okay, that's -4c minus 8, because -4 times 2 is -8, plus 9. So that ends up being -4c plus 1. So that's the answer I'm looking for there. All right, why don't you take a minute and try number 17. All right, let's go through number 17 here real quick, see how you did on that one. So once again, hopefully you put the right answer in, but if you didn't put the right answer or get the right answer, that's okay. This is called learning for a reason. So let's see, f of 7w minus 5 gives me -4 times, instead of x, I'm putting 7w minus 5 in, plus 9. So remember, I'm pulling off this f of x over here. And then I'm just distributing. So that's -28w plus 20 plus 9, or -28w plus 29 is what we're looking for there. Okay, so hopefully that's the answer you came up with. All right, so we talked about this function notation stuff is not all brand new. Some of these problems are a little more new, but the notation itself is stuff you've seen before. Now we're just going to expand upon it. Why don't you guys go ahead and try to go through the rest of this worksheet, the problems we haven't done as examples tonight. Thanks.